All right, so for 6.4 notes, these are relationships in triangles. Our goal is to use properties of inequalities in triangles to determine information about angles and sides. So our goal is to use properties of inequalities in triangles to determine information about angles and sides. So what is an exterior angle? An exterior angle is the angle between an extended side and a side of a triangle. So let's look and see what this would look like. So here we have a triangle. If we take one side of the triangle and actually extend it like this, then this angle that is formed with this extended side and this side of the triangle, this angle right in here is an exterior angle. So we're going to label this angle 1, this will be 2, 3, 4. Angle 1 is an exterior angle. So then the rest of them, angles 2, angle 3, and angle 4, are interior angles. So an interior angle is the angle formed between two sides of a triangle. So the angle formed between two sides of a triangle. The remote interior angles are the interior angles that do not touch an exterior angle. So you'll have remote interior angles to an exterior angle. So let me show you what I mean. I drew in the exact same diagram that we had up here. So we have this exterior angle 1. Angle 3 and angle 4 are the remote interior angles of exterior angle 1. So angle 3 and angle 4 are remote interior angles of angle 1. So the way that we are going to define this is these are the interior angles that do not touch the exterior angles. So in this case, when we're talking about angle 1, 3 and 4 do not touch it. So 3 and 4 are the remote interior angles of the exterior angle 1. The triangle sum theorem. The measures of the interior angles of a triangle always add to 180 degrees. So the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 will always equal 180. So we have some examples that are going to use this triangle sum theorem. So 65 and 57. What is the third angle, this angle right here, that we would have to add to it to get to 180? So what you can do is you can fill this in. 65 plus 57 plus x equals 180. 65 and 57 adds to 122. Subtract 122 from both sides. And we're going to get that x is 58 degrees. So this angle right here is 58 degrees. Now there's lots of different ways you can go about this. I'm not going to be picky on how you are showing your work here, but as long as you show me something, whether it's 180 minus the 122, that's essentially what we're doing when we're solving. But on your assignment, you always have to show your work. So make sure you have some way to show work for that. On number 2, this angle here, that is a mark showing that that's 90 degrees. So those two sum add up to 130. So we have 180 that we need to get to. We've already used 130. So this would be another way you could show your work, knowing that that angle right there has to be 50 degrees. Number 3 down here, 180. You could subtract 130 first. You're left with 50. Then subtract the 20. You're left with 30. This angle right here is 30 degrees. So there's lots of different ways you can go about showing and representing your work here. So 50, 85, and x have to add to 180. 50 and 85 add to 135. subtract the 135 on both sides, and we're going to have x equals 45. So that would be how you would go about solving for the third angle in a triangle. Okay, so the triangle exterior angle theorem says the sum of the exterior angle, or the measure of the exterior angle of a triangle equals the sum of the measures of its remote interior angles. So what it's saying is 1 is equal to 3 and 4 added together. Okay, if 1 is the same as 3 and 4, 1 has to be bigger than 3 or 4 on its own. That's why this says this allows us to further conclude that an exterior angle is greater than its remote interior angles. So we are going to go ahead and just prove this. If we have a couple different things here, we know that the measure of angle 1 plus, measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 has to be equal to 180 because of the triangle sum theorem. We also know that angle 1 and 2 has to add up to 180. That's from the linear pair theorem. Okay, so we know then that since both of these are equal to 180, we can set these two sides equal together. So then we have the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4. And all we're doing there is we're substituting. So that was substitution. Then what you're going to do is you'll see that the measure of angle 2 is on both sides. So if you subtract the measure of angle 2 on both sides, what we're left with is the measure of angle 1 equals the measure of angle 3 plus the measure of angle 4, and that was from the subtraction property of equality. And there we have that, let me get my pointer, the exterior angle 1 is equal to the sum of the remote interior angles, so the measure of angle 3 and 4 added together. And so that would be your proof for that. That's how we get to that conclusion. So here you can do these in a number of different ways. You can use that idea of the exterior angle being equivalent to the sum of the remote interior angles, or you can use the triangle sum theorem. So I'll show you both ways. So for this first one, since 115 is the exterior angle, the remote interior angles are x and 85. That means that x and 85 have to add to 115 degrees. So what we can do then is we can solve for x and find you're subtracting 85 from both sides. And you're going to get x is 30 degrees. So that would be 30 degrees here. And you can double check that, because if you looked at the linear pair, a lot of you guys are more comfortable. I'll work with a different color here. A lot of you guys are more comfortable seeing that that's a linear pair and knowing that this angle here is 65 degrees. Well then, 85, 65, and x have to add to 180. So double check that. 85 plus 65 plus 30 is equal to 180, and either way, you have x as correct. So using either of those methods would allow you to see that x has to be 30. So let's mark this one x too, just so that we're consistent. 156 is your exterior angle. 56 and x are going to be your remote interior angles. So 56 plus x has to add to 156. Subtract 56 on both sides. You're going to find that x is 100. Okay, so we found that x was 100 degrees. If we wanted to use the linear pair theorem, then we could figure out what this angle here is. And knowing that those are linear pairs and they have to add up to 180, that angle there that I marked would have to be 24 degrees. And from there, you could use the 24, the 56 to figure out that x has to be 100. 56, 24, and x have to add up to 180, and you would find that x would have to be 100. All right, so moving on to that third example. This is now going to be, this is actually not the exterior angle. I'm going to show you why this is not an exterior angle. If it was an exterior angle, this would be extended, this would be the side, the exterior angle would be here, or this side is extended, this side is a side, and this would be your exterior angle here. So X, even though it is exterior of the triangle, that is actually not an exterior angle. Oops. That is actually not an exterior angle. Instead, that is just a vertical angle with the third angle of this triangle. So this one, you're just going to use the triangle sum theorem to figure out what X is. Vertical angles, remember, are always going to be congruent. So if we have 20 and 35, what would be the last angle that would make it add up to 180? So 180 minus the 55, you're going to be at 125 degrees. So X has to be 125 degrees here. All right, so explaining why the measure of angle 1 has to be greater than the measure of angle 4. So we do know that because the measure of angle 1 is an exterior angle to this angle and this angle, that we'll call this 5 over here. If the 5 and 3 have to add to 1, then the measure of angle 1 has to be greater than the measure of angle 3. We already know that much because 5 and 3 have to add to the measure of angle 1. So that is kind of the like an extra from the triangle exterior angle theorem. We also know that the measure of angle 3 has to equal the measure of angle 4 because those are vertical angles. So the vertical angle theorem tells you that those are the same. Then with substitution, you can say that the measure of angle 1 has to be bigger than the measure of angle 4 since 4 and 3 are the exact same, and you're just using substitution there. And that's how you would go ahead to explain that the measure of angle 1 is larger than the measure of angle 4. All right, on to the last page. All right, so angles and sides. The longest side is always across from the largest angle. And the smallest side, or the shortest side, is always across from the, should be smallest angle. Smallest angle, there we go. So here, your longest side, your biggest angle is 100. So your longest side is across from that. So your longest side has to be segment AC or side AC. Now the next largest angle is 50 degrees. So 50 is across from BC. So that's going to be the middle side. And then the shortest side is across from the smallest angle. So that smallest angle was 30 degrees across from BA. And that's how we're going to do this. So what I want you to do, I want you to hit pause here and try number 2 on your own and then hit play and see if you can get it right. So I found that the measure of angle F was 80 degrees, which would have been the longest the largest angle across from this EG side. The middle angle is 55 across from GF or FG. And then 45 is your smallest angle across from the EF side. Next, we have in number 3 and 4, we are given the side lengths, and we have to name the largest angle, middle angle, smallest angle. So again, 6, 8, and 10. 10 is going to be the largest side here, so that's across from angle A. Change colors. 6 is the middle one. Just kidding, 6 is the smallest one. So that's across from angle C. So I can label that one. And the 8 is the middle number there across from angle B. Go ahead and try number 4. So hit pause, try number 4. Then you can hit play to check your answer. So the largest angle is going to be angle Z. The middle angle will be angle Y. And the smallest angle will be angle X. The triangle inequalities theorem says the sum of the length of any two sides is greater than the length of the third side. So in any case, if you take side XY and side YZ, that has to be greater than the ZX. Now, if we were in class, I have a pretty good demonstration to show you why. But if you take your two shorter sides and you stretch them out as far as they can go, if they cannot connect that third side, then it's not going to work. So if those two sides together are shorter than that third side, then you'll never be able to reach to form that triangle. It might be very hard to kind of describe what I would show you in class. But so you add your shorter two sides. If it's bigger than the third side, the longest side, then you're golden. So we look here at the longest side. The longest side is 8. So do 4 and 1 add to bigger than 8? 4 and 1 is 5. 5's not bigger than 8. So we have 4 plus 1. That has to be bigger than 8. 5 is not bigger than 8. So we say, no, it doesn't form a triangle. This one, your longest side is 10. So 8 plus 6 has to be greater than 10. 8 and 6 is 14, which is greater than 10. So yes, this forms a triangle. Go ahead and try the last two. This one should be marked 4. So try 3 and 4. Once you think you have them, go ahead and hit play and see if you're right. So for number 3, that one might be tricky, but 30 is not greater than 30. It's equal to, but that doesn't say or equal to. It just says is 30 greater than 30. So your answer is no, that doesn't form a triangle. For number 4, you're going to have 80s greater than 100. That also does not work. That is no, that does not form a triangle. So the only one that forms a triangle here is number 2. That is it for notes. If you have any questions, let me know.